There we go. Okay. Today we're talking about Chapter 7, Section 5, which is entitled Parts of Similar Triangles. Once again, we're going to break this lesson into two separate virtual lessons. We'll do the first half of the lesson today and the second half of the lesson on Friday. So what we're talking about here are bits and pieces of similar triangles. Now, we've already spent an entire couple weeks talking about the various parts of triangles. You've got your 4 different types of line segments in a triangle: your angle bisector, your perpendicular bisector, your median, and your altitude. So what we're saying here in this section is that if two triangles are similar, the lengths of several of those parts are also proportional to side lengths. The angle bisectors are proportional to the side lengths. The altitudes, their lengths, are proportional to the side lengths, and the medians, their lengths are proportional to the side lengths. Okay, so it's worth noting that those 3 types of line segments in a triangle, they share the same proportion between a pair of similar triangles as the side lengths and the perimeters of the triangles themselves. So basically, it just gives me more problem types that I can assign you where you have to go in and find a missing length. It gives me more options on how to write the problems. Okay, so we're going to go through a few examples here, and I'm going to ask you some questions along the way to have you respond in chat. So we don't have what happened in my 4th period class today happen, where I had to kick somebody out at the end because they weren't still sitting at their computer paying attention to me, which makes my blood pressure go up. Okay. So here we go. We're looking at, here we've got a pair of triangles that are similar. We've got a similarity statement right here, which says that they're similar. We're asked to find the value of x. Now, x is not a side length. X is not a side length on either one of these triangles. You need to remember that this similarity statement tells us that the proportion AB over FD equals BC over DG equals AC over FG. Okay, we need to remember that. That's the key to similar triangles, is that the sides in similar triangles are proportional. Now, if we look at that, we don't need that much of that proportion, because the only numbers we know that fit that proportion are AB and FD. But remember that all 3 of these fractions are equal to each other. So what we do is we're going to set up a proportion, but that proportion will only consist of one set of sides, which is the set of sides that we know, AB over FD. And then on the other side, we're going to put the corresponding corresponding angle bisectors, AP and FQ. Okay, because the angle bisectors of these triangles have the same proportionality as the side lengths. Okay, so that means we're going to be setting up and solving a proportion here. 15 is to 12. That's the side lengths. 15 is to 12 as x is to 8. Those would be our bisectors, x and 8. From there, it's just a simple process of cross multiplying and solving for x. So we've done that about, what, 100 times now in this chapter. 12 times x is 12x. And then we've got 15 times 8, which is 120. So we have 12x equals 120. And then we divide by 12 to get x by itself. And we get our answer, x is 10. Which in turn would mean that AP is 10 units long. Okay, so in general, there's not really going to be any tricks to this. It's just going to be setting up and solving proportions. There's not going to be any trick questions. There's not going to be any attempts to screw you up. It's just to check and see, do you understand how to set up and solve a proportion? Okay, that's what we're dealing with today, is can you set up and solve a proportion? So there's our first example. Any questions before we advance? All right. So Here in example 2, the first check for understanding, what kind of line segments are MP and YQ? Which type of line segment are those? Are those angle bisectors? Are they medians? Are they altitudes? What are they? Which one of those three? Are they angle bisectors? Are they medians? Or are they altitudes? Type that in the chat. Who's brave enough to be the first one to take a shot? Okay. Those are not angle bisectors because they do not divide the angle, in this case M, in half. So that's how we know it's not an angle bisector. Altitude is correct. These are altitudes. We've got here a 90-degree angle. Everybody see boxy here? Boxy is indicating that we are perpendicular to one side and we pass through the opposite vertex. That makes these pieces altitudes. Now, really, that's only important because, again, altitudes are one of the ones that work. So then the next thing is, which one of our 3 similarity rules, angle-angle similarity, side-angle-side similarity, or side-side-side similarity, do we have shown in this picture? Because we weren't given a similarity statement. So which one of those rules guarantees that these are similar triangles? Is it side-side-side similarity? Is it side-angle-side? Or is it angle-angle? Which one of those 3 rules do we have shown in this picture that guarantees that these are similar triangles? Which rule? Very good, Dewan. Very good. Okay, we got 2 sets of angles. We've got angle K is congruent to angle X. Again, they're each marked with 1 arc. And we have that angle L is congruent to angle Z because they're each marked with 2 arcs. That is 2 sets of angles. So that gives us our triangle similarity. KLM is similar to triangle XZY. Because this picture is showing angle-angle similarity. So unlike the last example, they did not give us a similarity statement. We have to recognize triangle similarity, and we have to be able to match up the angles correctly, okay? The reason for that is we've got to know whether or not we've got the right information. Well, that similarity statement would then in turn tell us the proportion that KM is related, this first and last letter, to XY, which is one set of sides that we have in our picture, okay? So we are going to use this piece of the proportion because we've got KM, which is 20, and XY, which is 15. We know those lengths. On the other side of the proportion, we're going to put our altitudes. Remember that the altitude from triangle KLM will have to go on top, so that's MP, goes on top. And our altitude from triangle XZY will go on the bottom. That would be YQ. Okay, but again, those pieces make up our other fraction, 16 over X. So what I'd like you to do now is set up and solve the proportion based on what I've written up there on the screen. And in the chat, type the value of X. Look at you guys working ahead. Okay. All right, so X seems to be a consensus is equal to 12, and I'm pretty sure you are correct on that. Again, we would plug in our side lengths. 20 is to 15, as 16 is to X for the altitudes. We would cross multiply, which would be 20X and 240. And then we would divide each side by 20, which gives us 12 for X. Okay? Any questions so far? Again, we're not trying to trick you here. We're just trying to establish that these 3 types of line segments, altitudes, medians, and angle bisectors, in triangles are proportionally the same as the sides. They are proportional to the sides. Any questions on this second example before we advance to the last slide for the day? All right. Nobody's jumping at that opportunity. Okay, so here we have a third example. This is about as complicated as these are ever going to get. My first question is, did they actually tell us anything about enough to set up the proportion right away? Do we know a full set of sides? Do we know the length of one of the two other segments? What are we missing here? What do we not know? Well, they didn't tell us an entire side length. Okay. Now the markings, this is also a little bit confusing here. These markings are indicating that these angles are congruent. So we have angle STR. My angle symbol kind of bled in there. Angle STR is congruent to angle VWU. Okay, that's marked with one arc. Those are not four separate angles being marked. That's two sets. That's two angles being marked. And we've also got that angle S is congruent to angle V because they're marked with two arcs. So once again, in our head at least, we should be establishing that yes, we do have similar triangles. STR is similar to triangle VWU. Okay, because of the angle-angle similarity. Okay, so that part we should be doing in our heads because they didn't tell us the triangles are similar. We should be recognizing that they are similar based on angle-angle similarity. So we go over here and we say, all right, well, that's all fine and dandy, but we still do not know what the entire side length of any of these sides is. We don't have a number that represents the full side length of any of these triangles. So how do we find the length of UV? What is the length of UV and how do we find it? Anybody? And type it in the chat. What is the length of UV? Okay. So the length of UV is 6. I would agree with that. How do we find that? How do we know it's 6? Everybody's typing 6. That's good. But how do we find that length? How do we know that UV is 6? Okay, Audrey says 3 plus 3. All right, Isaac says they're congruent. What are congruent? There we go. UG and QV are marked as being congruent. Or UQ, rather. UQ and QV are marked as being congruent, which means that QV is also 3 units, and the entire length of that side would be 6 units. Using that same argument, PS is our X, and it's marked as being congruent to RP, so that is also X, which means that the entire length of that side would be 2x. By the way, there should be 2 marks on each of those. So if you've got paper notes in front of you, you should fix that. Okay? So that allows us to set up our proportion because now we have our set of sides, 2x and 6 are our side lengths. We can say RS is to UV as, that's our side lengths, our yellows. And then the other side, we can use these medians, which is what we're looking at here, TP and WQ. Okay, those medians, TP and WQ. So again, we set up and solve the proportion here. RS is 2x, UV is 6. TP is 13.5 and WQ is 9. So cross multiply, solve for X, and tell me in the chat what is the value of X. Everybody's working ahead of me. I must be talking too much. Okay, good. We got 4.5 for X. I would agree with that statement. We cross multiply. 6 times 13.5 is something. Probably should have my calculator handy next time. 13.5 times 6 is 81. That's right. And then on the other side, 2x times 9 is 18x. So then we would divide both sides by 18 to get x by itself, which would give us that x is 9/2 or 4.5. I would accept either answer. Given that there is a decimal in the problem, it's perfectly fine for us to give a decimal answer. Okay? So, any questions? We've finished up the notes for the day. What questions do we have, if any?